The first one is LIN. It's called as local interconnect network. I'll say basically the first one, a very easy one, and also a very less costly. It works on a master and slave system. So basically, one ECU will be your master, and the rest one, all ECUs will be your slave. And only masters. So it happens in this way that only master can send and receive both, and the slave only can send the messages. So now it's a time triggered protocol also, and the speed is very less here. You can see it's only 20 kbps. So it's a low cost and it's a single wire implementation. The whole link concept will be running on a single wire concept across the wiring harness. Nowadays, we don't use LIN in most of the ECUs. We use only where on and off devices are required. Suppose my car seats or door lock. So the input is like 0 or 1. That's all. And it's not very critical information. So for that, we require the LIN concept. So what happens in automobile industry, when we design the topology of the car, we also take care of the cost, right? We also take care that if okay, if I can cut short this part or this part of the topology with LIN, of course my cost is going to be reduced, right? And this information, the part like car seats and the door locks, sunroofs, rain sensors, door mirrors, they are not very critical as like my airbags or my engine ECU or my cluster, right? So we include LIN systems in this part of areas where the information is not very critical, or we only want the inputs to be in an on and off stage. LIN will be used in this kind of systems, and also it helps. It's very much helpful in cost cutting in the OEMs. After that, we have CAN. So CAN, after LIN, we have CAN, that is controller area network. It is intentional. It was initially developed by Robert Bosch in the 1980s. You will find that CAN specifications to be in by Robert Bosch only these days as a part A and part B specification. It was developed in 1980s, I'll say 1980s or 81. The CAN control system operates over two wires at much faster rates than the any previous communication protocols what we saw in the LIN. So LIN speed was 20 kbps, right? Here the speed is 1 mbps in CAN controller area network systems. This today it is supported by several manufacturers of integrated circuits, whatever we'll say ECUs, right? We're using mostly CAN in all the Indian OEMs, whatever the Indian cars you will see, they all are running on CAN systems. Everything, they all have CAN protocols and the LIN protocols. Most of them will not use Ethernet or FlexRay. As of now, as per my knowledge, none of them are using. What else it does is message frames are transmitted based on the priority of event based messages. As I told you, right, there should be some logic where we decide the priority of the information shared across the bus. As I gave you the information that my car is going to get crashed, and I need airbag to be deployed first, then I need the music information to be passed, right? In that case, my priority message, this prioritization of the messages will be helping me to decide which message is more prior and which is more important to send on the bus, and which is like more critical also. So for here, I'll just explain you the example of, I'll explain you the example of airbag. What happens with the airbags, where we have heard, right, when any accident happens, airbags will be deployed. We'll see a kind of big balloon on the car on the steering column, right? So airbags works by inflating as soon as the vehicle starts to slow down as a result of any accident. Kind of speed, suppose I'm going by 100 speed, and at a moment my speed is cut short to 0, then it would deploy. How it happens, the ABS, or I'll say airbag messages will be, the messages will be given from EMS, will be given as a circuit or in a circuit to ABS systems. It generate, there is a circuit inside again in the controller. The circuit passes an electrical current through heating element, which turn ignites, or which will ignite the chemical explosive kind of thing. And because of that only, there will be harmless gas, which will be the bag which you have seen on the steering column, right? That is a nylon bag. In that only, that the gas rushes and then it will be deployed, and that works in that way. And here we need the CAN protocol to prioritize the message. Then the speed also, here you can see in the LIN the speed is only 20 kbps, but in the CAN the speed is 1 mbps. Basically in the normal OEMs we use only 500 kbps only till now. Most CAN, whatever the ECUs we have, they supports they supports, I'll say, we only use 500 kbps speed, transmission speed. Next is, it is a robust, cost-effective, and cost-effective general control network, and it is widely used in the current automotive industry. As like CAN, as I told you, even Mercedes and BMW also uses CAN protocols in their topologies, because again I need not to connect everything on Ethernet, where I can connect the CAN and where my work can be done only on the speed of 1 mbps transmission speed. Why there is a need to connect on a very high speed network? Why I need to waste money on my Ethernet network? I can only go with the CAN. So in that case also it is used widely across the industry. Okay, the now we'll just discuss about the current trends in the industry. The first here I have written is Ethernet network, right? What is Ethernet and how it works? Like Ethernet, we all know, right? Ethernet is nothing but a normal cables, right? We connect our laptops. The Wi-Fi is connected, so it should be very familiar to most of us. You might find yourself using it to connect your home computer, or your router or modem, right? And but in when it comes to the automotive industry, it's a kind of wiring where we are using Ethernet cables to connect, as we need more of the speed. So the future, I'll say, or not I'll say future, in the current scenarios only, every normal OEMs, they all are working on the Ethernet network. So if someone is very much wise versed in Ethernet networks, of course there is so much scope in the automotive industry for them. If someone who's in-depth knowledge of Ethernet networks, they are very good for today's world, because every company now they're working on the Ethernet. The main challenge is to cut down the cost which is included in this networking. As we know, there will be a lot of wiring to be going to be done, because we need to share the information. Here you can see the autonomous cars, right, or electric vehicles. In that case we need not to even 1 second or 1 millisecond or 2 millisecond delay in the messages is also very much what I'll say, not good for us. It's not, it's very bad for a autonomous car to have 1 millisecond delay also in the information. So every Ethernet network is very much responsible to run the autonomous cars. The next current trend here I have written is advanced driver assistance system, which is called ADAS. That is also a current technology, or I'll say current area where mostly OEMs are working. To for the driver assistance systems, we have all this ADAS features, and there is a separate teams for this. These all you can see ADAS in every OEM. There will be a separate team for ADAS systems. Next, we have autonomous cars. You all have read these days, and you all know that what is autonomous car, right? A car basically which drives by itself, right? Autonomous cars. I think everyone knows an autonomous car is a vehicle which is capable of sensing its environment, what is happening in and around, and operating without any human involvement, right? Human passenger kind of thing is not required to take control of the vehicle at any time. Complete car will be taking care of itself. And I must say, many OEMs uh, uh, have this kind of prototypes with them, where they have shown the autonomous cars. And it's not only a complete autonomous. When it goes to when we go through the Society of Automotive Engineers, that is SAE, they will basically devise this autonomous car concept into 6 different levels, where will be 0 will be no automation, and 5 will be full automation. In between also we have 1 2 3 4 levels, where we have driver assistance systems, ADAS, I told you, and then we have partial automation, conditional automation, and high automation. It has different levels, and again in the OEM there are different teams which are working on these levels of driving automation. So it's not only the completely automated cars. In between also we have levels where the autonomous cars are getting, we are working on those. The future, which is electric vehicles, as we all know, because of government guidelines and everything, we are in a situation of to bring up the electric vehicle. So if someone wants to come into the automotive industry, of course the future is autonomous cars and electric vehicles, where every OEM is putting their best foot forward to bring these two concepts into the market on a very I'll say market price level, because you know, right, electric vehicles these days in the market are very costly. So there will be a good opportunity if we can invent something or we can do something to bring down the cost in the future. And then the next is remote diagnostics. What is remote diagnostics? Remote diagnostics is something uh, where we can do, or where we can diagnose that what has happened to the car by not going inside the car, just by sitting in our home, like how we are doing work from home, right? These days many companies have given work from home. Same way, if suppose if something happens to the car, I can take control of the car or the ECU in my lab, and I can work on that. So that will be remote diagnostics. In this today's automotive industry, I'll say we are doing it, the remote diagnostics, of course. There will be something called FOTA, which is firmware over the air, where we deploy the softwares, like how we do the software update in our mobile phones, right? Same way, if there is any update on any of the ECUs, okay, let me clear you here. These ECUs, right, what you are seeing in the pictures, these are also having softwares. These every ECU have one software, and for this only there will be same way how we get the updates on our phones, right? There should be, or there will be update in the future times for each ECU, and that how we can achieve if we do remote diagnostics. That is a very easy way. If we are very well and good with remote diagnostics, we can do a software update. Or if suppose some problems happen to the car, you need not to bring the car to the workshop. Now what happens if we find some issues in the car? We will take it to the nearest workshop, right? And the mechanic or someone who, the workshop person, will diagnose the car, and they will say, okay, this is this problem you have, and we need to do a software update, a software patch is required to fix this issue. Or if it is a hardware issue, they will tell you this is the hardware issue, you need to fix this hardware. So in this case, what you can do using the remote diagnostics, you raise a ticket to your vehicle manufacturer, whoever has the car you have bought. Now it went to their service stations or service people who are providing the service on that very component. You give all the information, they took the control of your car, they fix the issue, and what, you are sitting in your home and the car is getting fixed. You, if there is possibility to get it fixed by there only, and if you need not to bring the car to the workshop. So these and all we can do. Another concept of remote diagnostics, suppose I'm sitting in my home and I need to test one ECU, how you do the testing for the codes and everything, right? Same way, we also do the testing for ECUs. We also test the wiring harness. We also test each and every functionality of the car. So now, if I have a power of doing remote diagnostics, I can sit in my home and I can do the remote diagnostics by sitting in my home. I need not to go to office. I can take the remote of my ECU and I can do all the testing whichever is required. So in this way, remote diagnostics is going to help me. Now, coming to the evaluation in the field, the first is growing demand. What is that? We know that if there is a rise in the middle class income and young population, of course, we need car, right? We are asked to buy, okay, we need cars. So there will be a growing demand in the future. For information, already India is the fourth largest auto market in the whole world, and it is expected that it will be on number three by the 2021. So there is a growing demand of cars in our market. I'm talking these all in perspective to India. Second is the opportunities which is there in the Indian market growing day by day. And so India could be the leader of shared mobility by 2030, providing opportunity for your electric as well as autonomous cars. We can work on both. Already we are working, and already we have the running models on the road. If you have seen Mahindra Reva, or if you have seen Kona these days on the road, they all are EV vehicles. And there is a huge focus to shift the complete target on the electric vehicles to reduce the emission and to match the government guidelines for pollution and the emission levels of the car. Then there is a rising investment in the auto sector. India has significant cost advantages, if I'll say. Auto firm can save 10 to 25% or 26% on operations with compared to America or Europe. You have seen there are so many new companies which are coming to the India, right? This is because of this only. And there is a huge, what I'll say, investment in the Indian market. Next is the policy support by the government. Of course, the government aims to develop India as a global manufacture centers for the car or for the automotive industry, and reforms like the GST, which you have seen, GST on EV vehicles, especially if I'll say, it has been cut down from 12 to 5%. So policy supports by the government also is very much beneficial for the automotive industry, and these will be the evolution here. And now coming to the most important thing for all of us, how about the career? What should be the career path if you are choosing or if you are willing to be the part of automotive industry? What and all you should do, it is all given here. First is, if you are a fresher, um, and if you are very much like into the cars, or if you like to be the part of this industry, I'll just say go through the basics of automotive communication, that is CAN, LIN, and Ethernet, which we'll be giving in this complete course. You should one should be very much well versed these protocols levels like CAN, LIN, Ethernet, etc. FlexRay. All these are very much required as a basics. These are the basics here. Then one should learn what is vehicle diagnostics based on the above protocols, that is CAN, LIN, and Ethernet. And same way we have another protocols for diagnostics, which will be UDS. Same way UDS is on CAN and LIN also, KWP, OBD, and all. If you want to be the part of ECU development team, the controller units which we saw, you once should learn the Java, C Sharp, and Python. Yes, of course, if I told you in the starting, very starting, if you're from mechanical, electrical, electronics, or even if you're from computer science background, you can be part of automotive industry. There are many huge number of people who are working on ECU development part. All those suppliers, if I'll say Bosch or Continental, they have their specified teams who are proper software engineers who are working on Java, C Sharp, and Python to run the codes inside the car. Then, if you are into the data analysis part or the cloud computing, yes, these days OEMs are working on the cloud computing and data analysis part also. Whatever the data, suppose if we say V2V, right, vehicle to vehicle communication, if we'll say, how it will be done? Of course, it should be done through the cloud only, right? The one vehicle is sharing the information with the others. So all these will be, I'll just explain, I'll give you the brief introduction here, that what and all if is required if you want to be in the automotive industry. This will be the career path. Coming to the job opportunities, what we have today, of course, if there are embedded developers who are responsible for the codes which are given in the ECUs, electronic control units. Here I have given very few examples. There are many more other designations and the rules and responsibilities in the automotive domain. diagnostics engineer. These are diagnostics engineer will be responsible for doing the testing as well as the developing of the diagnostics on different protocols on the car level. Then we have vehicle architecture design engineer. Suppose I'll say they will be responsible for the in-vehicle networking concept, how the vehicle architecture is going to look, how many ECUs we require, how they should be connected, and all this that will be taken care by this team. Then we have validation engineer. They will be responsible for validating each and every functionality wise, what and all components are working, what and all the concepts which are included in the car. Suppose there is parking assistant, or I'll say there is something in the doors or something with the lights. They all are functionality wise. We have different kind of validation engineers. And then software engineers of again, which will be used, they will be taking part in the data analysis and my cloud computing or the development activities. They will be taking part of these very jobs in the market. So I think I'm done with today's presentation and the webinar session.